All right, moving on to number 15. 15 says, if increasing the concentration of A in a chemical reaction causes no increase in the rate of the reaction, then we can say what? So one of these will be true. A says that A is a catalyst. That doesn't make any sense. So A is just out of the question. B says the reaction rate is 0 order in A. But be careful, look at the writing. It says the reaction rate is 0 order in A. Now compare that to choice C, which says that the reaction rate is 0 order in A square brackets. You see the difference? So if we were doing this quickly, we might choose B, but in fact B is incorrect. And the reaction rate must be 0 order in A. And you'll recall, if you're doing these in order, and hopefully you are, we saw among the earliest questions on this sheet that, and I'm just going to make this the simplest case with one reactant. As I was saying, we saw that anything raised to the power of 0 is 1. And so if indeed the reaction is 0 order in A, then for sure if I increase the concentration of A, it doesn't have an effect on the rate. So far I can see that C is correct, but let's just evaluate the other ones as well. D says that the reaction rate is first order in A, and that would not be possible because if indeed this did have a power of 1, then increasing the concentration of A would have the effect of increasing the rate. So that's a no-go. And finally, the choice of E says A is not involved in the reaction. Well, it's kind of irrelevant, isn't it? It's kind of a silly answer. So the correct answer to 15 is C. The reaction rate, the reaction is 0 order in A. That's why by increasing the concentration of A, it has no increase on the rate of the reaction. So that's number 15. Let's keep going with 16. We'll just turn this around to give us a fresh side. And again, if you're doing these questions in order, we've already developed the half-life equation for a first order reaction in which A goes to product. And just to remind you that the following rate law for a first order is given, and ln of A is equal to the ln of A initial minus KT. And we saw that when enough time has passed such that we've reached the half-life, then we write T as T1 half, and it means that the concentration of A at that point in the reaction, the half-life, is equal to 1/2 of A initial. And we saw that this equation really simplified to an expression for T, which is T1 half at that point. And it was simply equal to 0.693 over K. So if you're asked a question that involves this formula, you definitely don't have to show the derivation of it if you've remembered it, and I think you probably will, even though I don't encourage memorization. It's so simple, and if you've used it a few times, you'll simply remember it. So that's the formula, and it asks us to calculate the rate constant K for a first order reaction with a half-life given as 75 minutes. And so I don't have to use time in seconds. I can use time in the units that they've given. So really this equation just switches places here, the K with the T1 half, and K is equal to 0.693 divided by my T1 half, and that would be 0.693 divided by my 75.0 minutes. This is why The units of a reaction rate constant K for any first order reaction are just simply time units raised to the -1. For this particular reaction, if we plug those numbers into the calculator, we get an answer of 9.24 times 10 to the -3 minutes to the -1. And that, on our choice list of choices on the sheet of paper, number 16, this is choice D. Let's move on to number 17. And in 17, they're asking us for which of the following statements is incorrect. Which of the following statements is incorrect? So notice it doesn't say which one of the following, it says which of the following. So there could be more than one. And let's evaluate them one by one. And that's number 17. Okay? So here we go. Number 17. My hand out of the way. Okay. First one. Radioactive decay is a first order reaction. Radioactive decay. That is true. Remember, all things that decay radioactively, they are a single reactant, and they decay to their what's called daughter products according to first order reaction kinetics. And so A is actually a true statement. Statement B says half-life in a first order reaction is constant. The half-life of a first order reaction is constant. We've just done half-life in question 16, and we saw that for a first order reaction, the half-life is equal to this constant number, 0.693, divided by the reaction rate constant. So does the half-life change during the course of a first order reaction? We know that the rate does, right? But does the half-life change? No, it doesn't, because 0.693 is a constant, and this value K is also a constant. Its value does not change throughout the reaction. So that is also true. Remember, in this question, we're looking for the incorrect statement, one or more. For a first order reaction, it says the ln of A at time t divided by A initial equals KT. Now, if I just look at that, it actually looks familiar, and at a first glance, I might actually choose that as being correct, or describe that as being correct. But let's not look at it. Let's just write down what we know to be true for a first order, and that is that the ln of the concentration of A at any time is equal to the ln of the initial concentration minus KT. And this equation in the form that corresponds to the way it's listed in C is, so this is really not what's listed in C, this is what we are writing for a first order reaction, and then we'll compare with what they've written for C. It's the ln of A over A naught is equal to a minus KT. Now, this I know is correct. Now let me write down what they have written for C. They have written the following, that the ln of A at time t, that's fine, that's what that implies, over A initial is equal to KT. Well, right away they have forgotten the negative sign, so that's incorrect. Now we could also argue that since they didn't put these brackets here, that was really just the ln of A at time t divided by A initial. And I'll be careful on the exam to use brackets appropriately so that that wouldn't be ambiguous to you. But we'll say that it's incorrect because they've simply forgotten the negative sign. Okay, and That was C. We also have D. Let me make some space here. Let's evaluate D. In gaseous reactions, A can be expressed as concentration or as pressure. Well, that's true. In a zero-order reaction, the rate remains constant throughout the reaction. Well, in a zero order, we know that this is true, and anything raised to the 0 is 1. So yeah, that's true, that the rate basically is equal to the reaction rate constant, and so therefore E is also true. And so for number 17, we'll say that the incorrect answer is, or pardon me, the incorrect statement is C, and that's what they were asking for. Okay, good.